So we're going to look at an integral that can be solved via partial fractions method, and initial inspection may not reveal it, but what we're going to do is we're going to see if that denominator will factor. So I'm going to look at the denominator there, and I'm going to look at factoring by grouping. So in other words, I'm going to factor an x squared out of the first two pieces. I'm just going to do it off to the side here. Times x minus 1 minus, and now basically I'm factoring a negative out of here, times x minus 1. And now I see that I've got a common factor of x minus 1. So x minus 1 times x squared minus 1. The x squared, and then there's going to be a 1 here left when I factor out. I got another step of factoring to do, so I got x minus 1. This will factor its difference of squares into x minus 1 times x plus 1. So this is one where we have a repeated factor. So this is going to look a little bit different in that we need to account for the repeated factor. So when we go to break this up, now they are both linear factors, they're not quadratic factors. When we go to break this up, it's going to look like a over x minus 1 plus b over x minus 1 squared plus c over x plus 1 dx. So we have to account for the fact that there could be two of these because we're going to end up with three equations. We need three variables. So that's why we have to account for all of them. If this had been an x minus 1 cubed here, x minus 1 times x minus 1 times x minus 1, we would have had to do a over x minus 1, b over x minus 1 squared, c over x minus 1 cubed, and then d over x plus 1. So you have to account for each of the number of times it's repeated. Alright, now let's talk about that numerator. We know what the common denominator is. It's right here. So what you need to think about is what do you need to multiply each of these letters by to get to that common denominator. So a would be getting multiplied by one of the x minus 1s and an x plus 1. So a times x minus 1 times x plus 1. B has both of these already in its denominator. It just needs the x plus 1. And the c has the x plus 1, but it needs both x minus 1s. So c times x minus 1 squared. This needs to be equal to 2x squared plus 5. Now in this video, I specifically want to show how we can set it up as a system of equations to solve for a, b, and c, and then go back to our integral. So I'm going to use some scratch paper here because I want to just find the a, b, and c separately and then come back to our integral. So let's just focus on solving this for a, b, and c. What I'm going to do is I'm going to take a and I'm going to multiply everything out. So that's x squared minus 1 plus b times x plus 1 plus c times, I'm going to FOIL that out, x squared minus 2x plus 1. And that is equal to 2x squared plus 5. Now I'm going to distribute my coefficients here. So ax squared minus a plus bx plus b plus cx squared minus 2cx plus c equals 2x squared plus 5. So all I did was distribute the a, b's, and c's over the parentheses. Now what I'm going to do is I'm going to collect my coefficients by term. So I'm going to look for all the coefficients of x squared. I've got one here. So a coming across, a positive c, and 2 is on the other side of the equal. So a plus c must equal 2. X, none here. I've got a b minus 2c. And notice there's no x term over here, so it has to equal 0. And finally, my 1's. So I have a negative a plus b plus c has to equal 5. I now have my system of equations. From here, how you decide to solve it is completely up to you. You can use substitution, elimination, whatever method you like. You can use your graphing calculator, set up a matrix. I'll do that in a separate example. Let's say we want to do this one via substitution. Then what I see is I can solve my first equation. So I'm going to just come down here so we have enough room. So my first equation I'm going to solve for c. So c equals 2 minus a. Excuse me, I'm going to solve them all for my fault. I'm going to solve them all for in terms of c. So a equals 2 minus c. And here b equals 2c. Now I'm going to plug those in for a and b here to solve for c. So what that tells me is when I plug in this, I get negative 2 minus c plus 2c plus c equals 5. This can be solved for c. And then we'll work our way, and then once we have c, we can get a and b. So I have negative 2 plus c plus 2c plus c equals 5. So adding up my c's, I've got 4c. Adding that 2 over gives me 7. So c equals 7/4. From here we can find the other ones. b is 2 times c. So b is 14/4 or 7/2. And a is 2 minus c, or 8/4 minus 7/4, or 1/4. So coming back here, I'm going to plug those in for my a, b, and c. So we're going to skip that line there, come here. So I have 1/4 over x minus 1. Sorry, you can't really see that, can you? My b was 7/2, so plus 7/2 over x minus 1 squared. And finally, plus 7/4 over x plus 1 dx. We now have an integral we can do piece by piece. I'm going to do this a little quickly because I know the video is getting a little long. So 1/4 ln of the absolute value of x minus 1 plus 7/2. Now the most common mistake I see here is everybody wants to do this as a natural log. It's not a natural log. This is x minus 1 to the negative 2. So that means we're going to get the antiderivative of that to be negative x minus 1 to the negative 1 plus 7/4 times the natural log of the absolute value of x plus 1 plus c. I know I went a little quick through that one, but go ahead and double check that and you'll see where that came from. So I'm not going to worry about simplifying the logs in this one, but we will rewrite this guy. Sorry, that should be minus 7 over 2 times x minus 1 plus 7/4 times ln of x plus 1 plus c.